Now that we're going to be working with files, we have to be aware of working with error handling. And there's two levels of working with error handling. The first is just getting everything to compile. Now that we're dealing with files, we're dealing with a certain amount of unpredictability. Java knows that you're going to deal with files. Java knows that you're going to have to look at things that could go wrong. Because you have to remember that with a file, it could not be there. It could be already being used by somebody else. It could be written to, but you ran out of space on the hard drive. There's all sorts of things that can go wrong that has nothing to do with what you did wrong as a coder or what Java did wrong as a language, just external features. So that forces us to deal with exception handling. And you've learned that before. You've talked about that before. We'll cover that again in the demo. But beyond just simply dealing with the mechanics of exception handling, we also need to accommodate for what do we do when failures happen. That's a design question. So I want programs that I write to run well. There's nothing worse than you're out there playing a video game and you get some great progress in the game and you hit save and boom, it crashes. I don't know what happened. I don't know why it crashed. I don't know what's going on. I've lost all my progress. I hate that game at that point, right? I'm really mad about that. I mean, forget about that. What if you're working on a paper? You're working inside a Word. You've been writing for 10 pages and you hit save and the whole thing crashes. You don't know what happened to your work. You don't know where it went. At least in Word, you can copy and paste it and put it in Notepad and save it or something like that. You don't want the application to just crash. So as we're working on our solution, we have to consider how do we deal with these exceptions. We have to decide when do I just pass along these exceptions, these IO exceptions, and when do I do something with them? When do I try and do something useful with them? Now, the work we're going to do here isn't essential. We're not looking at doing the best error handling ever created by any programmer ever. What we want to do is be aware of the issue. We're not going to be asked to do a ton of super fancy stuff. I just want to put it in front of you like, hey, if this can't be saved, what do you want to do? The application we're being asked to build, there's not much we can do. If it can't save, then there's not much. But you can do all sorts of different strategies with that. So the question is, what do you do? What can you do as a response? So at a minimum, we need to deal with some try-catch or some throws logic. That's what we talked about. In Java, anytime you call a method that throws an exception that's checked exception, and all of the IO exceptions are checked exceptions, that means you have to do something with them. You have to either put a try-catch around it and says, yes, when this exception happens, this is what I'm going to do instead. Or I do a throws, which says somebody else above me will deal with it. But the logic of when do you use which is really tough. If you catch something you don't know how to handle, you could cause a big problem. So for instance, you're at home, there's a fire and a candle. What do? You blow it out. You know how to handle it, right? You don't need to set the smoke alarm off for that. Okay, there's a fire now on your stovetop. That's a grease fire. Do you know how to handle that? Maybe you do, maybe you don't. If it's in your wall, certainly you don't want to catch that exception. You don't want to just turn off the smoke alarm. I say don't worry about it. Because then what happens is something really bad happens, your house burns down, and the proper authorities weren't called. You don't know how to deal with that appropriately. That's an extreme example, but that's what we're talking about inside of the Java application. So the code you're writing, if you know what you should do when this exception occurs, you should trap it. You should do something about it. If you don't know what to do, then just send it along to the caller. And we'll see this when we get into the demo. We'll see this in the design. We'll see some of the choices involved. But what are the types of things you can do, and how do I know what to do within the application? That becomes a really big question. And so the next part is deciding just that. It's really a requirements decision for the most part of what do I do when a file is not working. If I can't write a line to a file, what should happen? Should you exit the program? Should you tell the user you can't write the line to the file? Should you try it again in some interesting way? What does it mean? So it depends on the nature of the program you're running. There's no default answer. So in the application we have, if we can't write to a file, well, you could ask the user, do you want to save it under a different file name? You could try and save it as a different file. It doesn't work if you're saving one monolithic file that everybody's saving to, things like that. So if you're running a bash program that needs to write to that specific file name because somebody else is expecting it and that file's in use, all you can do is fail, tell somebody you failed, and then come back and do it later on. I've seen applications, though, that are clever. They try it in some interesting way. I can't write to this file, so I'm going to write my results to a different file, still fail, tell people the results from this other file, and then have a task that comes along and picks up from one file and appends it to the other file later on. It's up to you to design. It's up to you to ask the right questions if you don't know. As again, in this class, I'm not expecting much. I'm not expecting you to do above and beyond crazy sort of stuff. But you have to figure out, like, what does it mean if I can't read a file? Does that mean you fail? It's the only file out there? It's the config file for the game? If that's not out there, there's nothing I can do? Or can I ask the user, give me another file? If I can't read this config file, tell me where the config file's at. What am I going to do from there? That's, again, partially a functional. It's partially a design-based thing of how is this system created. If I can live without the config file and run with some default config, then do that. Or I can ask the user. Or I just have to fail overall. Inevitably, it comes down to what's acceptable from a usability standpoint. What's acceptable from a user, what's acceptable from the people paying the deal, and that's where we're saying it's a requirements decision. It's something that you can't really decide on your own, but you can certainly raise the question. Often this stuff is skipped until you get to the coding phase. Often it's stuff that's not thought about because people just don't think about details like, oh, by the way, what happens if the hard drive is full? You're the one who has to think about it the first time because you have the exception that popped up. And then you just propagate. Just ask the question. In this class, you make up whatever you want to do. That's totally fine. We'll find something useful for it. You can't not deal with exceptions. You can always just have your program die. Hopefully you can do something slightly better than that. It's a great time to practice it. But don't worry if you're still learning, if this is really new to you, and you just know how to make it go to the next one. Start with there. Get your I/O working. Get your ability to write to a file. Then come back if you have time to go and make something fancier. We're going to see options to do in the demo, but for now, that's what we need to be aware of, is files need to deal with exceptions. Files need to deal with errors when I'm working with files, and I should plan for them. I should design for them. I should make my application be flexible around the different files that are in use.